This is Algebra 1, Spring Test number 11 study guide. Beginning with simplifying difference. Notice for problem number 1, it says minus in the middle. This is not multiplying polynomials, it's simply subtracting. What you have to know is since it says minus, that means all of the signs in the second polynomial are going to be the opposite of what they say. You still want to write it in standard form. Standard form means the largest degree is first. So negative 5x to the fourth minus a negative 7x to the fourth. That means plus a positive. So negative 5 plus 7 is positive 2x to the fourth. Notice we did not add the exponents right there because all we're doing is subtracting. We're not multiplying. The next biggest degree is x to the first power. Negative 7x minus a negative 9x. Minus a negative, again, means plus a positive. So negative 7 plus 9 is positive 2x. And then the last one are the constant terms. 5 minus a negative 5. Minus a negative, again, means plus. 5 plus 5 is 10. So 2x to the fourth plus 2x plus 10. We're going to do the same thing with number 2. Start with the largest degree first. It's w squared in this case. 7w squared minus 3w squared. 7 minus 3 is 4w squared. The next biggest degree is w to the first power. Negative 7w, again, minus 3w. Negative 7 minus 3 is negative 10w. Then the last degree is the constant. Negative 6 minus a negative 5. Negative 6 minus a negative means plus 5, which is minus 1. Number 3 is simplifying the product. Now what we're doing is distributing what's on the outside of the parentheses to everything on the inside. 5a squared times 3a to the fourth. First thing, 5 times 3 is 15. Then a squared times a to the fourth becomes 2 plus 4. Anytime you multiply in the same basis, you add the exponents. That's 15a to the sixth. Also, you have 15a squared times 3b. I'm sorry, 5a squared times 3b. Again, you multiply 5 times 3 and you get 15. But this time, it's not the same base, a and a. One of them's a, the other one's b. You still have a squared, and it's multiplying by b. So it says that it was a positive, so plus that. And these are not like terms, so this is all you can do with this. You cannot combine them from there. Same thing for number 4, 2n distributed to everything. Now it's a trinomial inside the parentheses. 2n times n squared. 2 times 1 would be 2. N to the first power times n squared means n to the 1 plus 2. That's 2n to the third for the first one. Multiply to 2n times the middle term. 2n times 3n is again 2 times 3, which is 6. N to the 1 plus 1, which is positive 6n squared. And also multiply 2n times the last term, 4. 2n times 4 is plus 8n. And again, one of them is n to the third, then n squared, and then n to the first power, so you cannot combine them. That's a simplified version. Number 5, we are still doing the product. Multiply 3p to the fourth times 4p to the fourth. 3 times 4 is 12. P to the fourth times p to the fourth is p to the eighth power, 4 plus 4. 3p to the fourth times 7p to the third. 3 times 7 is positive 21. P to the fourth times p to the third. Add them up. 4 and 3 is p to the seventh. 3p to the fourth times 4p. 3 times 4 is positive 12. P to the fourth times p to the first. Add them up. 4 plus 1 is p to the fifth. And finally, 3p to the fourth times 1 is plus 3p to the fourth. 8x to the sixth times 4x to the fifth plus 6y to the third. 8x to the fifth times 4x to the fifth. 8 times 4 is 32. X to the sixth times x to the fifth. You add 6 and 5, and you get 32x to the 11th. 8x to the sixth times 6y to the third. 8 times 6 is positive 48. But now you have different bases, x and y. So we'll simply write in x to the sixth, y to the third. You don't change those. You do not add 6 and 3 right there. And then again, number 7, we're distributing. 6a to the fifth times 8a to the third. 6 times 8 still is 48. 8 to the fifth times 8 to the third. Add 5 and 3, 48a to the 8th power. 6a to the fifth times negative 8b to the sixth. 6 times negative 8 is negative 48. And then you have different bases, a to the fifth and b to the sixth. So you don't add 5 and 6. It's simply a to the fifth, b to the sixth. Now you do not combine these two, 48 and negative 48, and get 0, because one of them is a to the 8th, the other one's a to the 5th, b to the 6th. You leave those simply just like that, separate. Write the polynomial in standard form. Remember, standard form is largest degree, then next largest, then next largest, then next largest. It counts down. Degree is the exponent. That's the biggest exponent there is. So remember, the sign goes with that. All of this is the term of the largest degree. Negative 3g to the third. The next biggest one is g squared. So it'll be positive, because that's the sign that goes with it, g squared. The next one is g to the first power. It is a positive 9g, so you put plus 9g. And then the last one is the one that doesn't have any degree, since it has no variable, the constant term, negative 8. This is written in standard form. Biggest degree, counting down or descending to smallest degree to no degree. Number 9 is find the degrees of the monomial, or the degree of the monomial. Remember, the degree of the monomial or the degree of the polynomial, if there's more than one term, is the largest one there is. So right here, the largest exponent, the largest degree is 6. So this is a 6th degree polynomial. Number 10 is finding the sum. This is just like finding the difference like we did on the first couple of problems. So you put the like terms together. U to the third, 6u to the third plus 3u to the third. 6 plus 3 is 9u to the third. Notice we did not add the exponents right there, because we were only adding the bases, not multiplying them. U squared is next. Notice there's only one u squared. They don't have one in the second polynomial. Positive 5u squared. So you simply list that one next. Positive 5u squared. The next biggest one is u to the first power. There's only one. Again, it's in that second polynomial, and it is negative 8u. And then the last terms are the constants, 5 plus 2. 5 plus 2 is positive 7. Here's your polynomial. 9u to the third plus 5u squared minus 8u plus 7. Number 11 says find a solution to the following system of equations. Doesn't tell you to use substitution, doesn't tell you to use the combination or elimination method, and doesn't tell you to graph them and find where they intersect. So you have to pick the best method. You can make this the substitution method if that's what you prefer, or you can make this the elimination method if that's what you prefer. We have coefficients 1x and 1y. And our x's are stacked on our x's. I know they shifted over a little bit because of the negative. And our y's are on the top of our y's, and our constants on top of our constants. So that part's good as far as elimination goes, but we don't have opposites. In order to make opposites, we need to make either 4, we either need to make 1 and negative 4 into opposites, or 4 for y and positive 1 into opposites. So that being said, we're going to go with the x's. We'll make those opposites. Either way, though, it's going to come out to be the same or nearly the same. In order to multiply x times something that gives you an opposite of negative 4x, you're going to multiply it by 4. So this times this is going to be 4x. But you can't just multiply it by the one term. You have to multiply, you have to distribute it to everything. 4 times 1y is positive 4y, and 4 times 4 is 16. So we converted that second equation. Let's take the first equation and bring it down underneath it. Negative 4x, just like it is, plus 4y equals 8. So now we have two equations, and we have opposite coefficients, 4x and negative 4x. When we combine those, we get no more x's. We eliminated them. When we combine 4y and 4y, we get a positive 8y. And when we combine 16 and 8, we're going to get 24. So we have a simple equation to solve. 8y is equal to 24. Undo 8 times y by dividing by 8 on both sides. So y's value is going to be equal to 3. Remember, that's not the answer to the solution of the system. That's only one value of its coordinate. We need to find the x value as well. Remember, you want to multiply, or you want to sub that in into the easiest looking equation you could find. The second equation looks substantially easier than the first one. So let's take that value, y equals 3, and plug it in or substitute it into that equation. Instead of x plus y, we'll say x plus our new value for y, 3. So x plus 3. In order to get rid of plus 3, we know how to undo that. We subtract 3. If you do it to one side, balance it on the other side, x's value is 1. So you have an x and you have a y value. Remember, in order to list a solution to a system, it's always x comma y or 1, 3. That's the solution to number 11. That's the one point that makes both of them true. 1, 3. Number 12 says the sum of two numbers is 73. Their difference is 15. Write a system describing a situation and solve it to find the two numbers. You have to know what sum is. That means plus. So two numbers, that's two unknown numbers. One of them's x, the other unknown is y. Remember, you can use any variable you want. So x, it says x plus y, because it's their sum, is equal to 73. The same two numbers, the same two unknown numbers, says their difference, which means minus, is 15. So x minus y equals 15. So here's your system of equations. The sum 73, the difference is 15. So they're set up nice and neat for the elimination method. That's the method it tells us to use. Remember, we know all of these coefficients are 1. What I mean they're set up nice and neat is they're stacked on top of each other, x's and y's and constants, and you have opposite 1y and negative 1y. So when you combine those two, they eliminate. When you combine 1x and 1x, you have 2x, and when you combine 73 and 15, you get 88. So 2x equals 88. Solve that by dividing by 2 on both sides. X's value, or the first number's value, is 44. Substitute that back in to find what the second value is. It doesn't matter which version you plug it into. That one looks the same as the other one. So instead of x plus y, we plug our new value for x in. Plus y equals 73. Our new value for x is 44. So 44 plus x equals 73. Undo this positive 44 by subtracting it on both sides. If you do it there, do it here. We have to borrow 13 minus 4 is 9. 6 minus 4 is 2. So y's value is 29. One of the numbers is 44. The other one is 29. Again, if you wrote this as a point, if you graphed both of the numbers, or if you graphed both of the equations, it would be written as x comma y, or 44, 29. (13) says solve using elimination. These are nice and neat. They stacked on top of each other. And you got opposites, 2y and negative 2y. So when we combine everything, 2x and 3x, you have 5x. 2y and negative y eliminate. 2 and negative 22 is negative 20. 5x equals negative 20. Divide by 5 on both sides. X equals a negative divided by positive is a negative. 20 divided by 5 is 4. X's value is negative 4. Take that value to find what Y is. Take one of the other equations. Use the first one if they look the same. 2 times X plus 2Y equals 2. Your new value for X is negative 4. So in place of X, negative 4. 2 times negative 4 is negative 8. Plus 2y equals 2. Undo your order of operations backwards. Addition and subtraction is first. That's negative 8. That means minus 8. Undo it by adding 8. If you do it there, add it to the opposite side to balance it. It'll cancel out, leave you with 2y equals 10. Then get y's value by dividing to cancel out multiplication. When you do it to both sides, y is equal to 5. You have an x and a y value. Your solution to your system, x comma y, is negative 4, 5. That's the one point when you graph those two equations. That's the intersection of them, negative 4, 5. Number 14 says solve this one using substitution. So remember, substitution looks and is easier for most people if they're written side by side instead of stacked. So all I did was move them to be side by side. Remember, it doesn't matter which one you sub in because both of them say y equals whatever that expression is. So take this value, 3x, and plug it in place of y. 3x equals x plus 8. Now you got variables on both sides. Bring the smaller 1x to the larger side by subtracting x. If you do it there, do it here. 3x minus 1x is 2x equals 8. Get rid of 2 times something by dividing by 2. If you do it to one side, do it to the other side. X's value is 4. You have x's value, plug it back in place of x. Y equals 3 times our new value for x, which is 4. Y equals 12. We have x comma y. We have both of them. So x comma y, 4, 12 is your solution. '15 says find the slope. Remember, your slope formula is the change of y sub 2 minus y sub 1 over the change of x sub 2 minus x sub 1. Remember, the change means the difference. If this is x and this is y, because remember they're alphabetical, and this is x and this is y, you can call this one point sub 1, this one point sub 2. If you mislabel that, it'll still come out to be the same. You can go the other way. It's fine. Most of us, when we see this, y sub 2's value is the one that comes up first, is 0, minus y sub 1's value is next. That's this one. Over x sub 2's value is 6, minus x sub 1's value is 3. 0 minus 6 is negative 6. 6 minus 3 is 3. Simplify this. The number 3 goes into both. It goes into 6, negative 2 times, and it goes into 3 one time. So your slope value, you don't need to write something over 1. Your slope value is negative 2 for these 2 points. Number 16, write a line parallel to this equation that passes through the given point. Parallel lines have the same slope. Remember, your slope is your m value. So y equals mx plus b. You're looking at that equation. Its slope is 7 over 4. So on your new line, the slope will be the same as that one, 7 over 4. It's going to pass through the point negative 4, negative 14. So now we're finished with this equation. We don't need it anymore. This is your x sub 1 value and your y sub 1 value. We're given a point and a slope. So we'll use point slope form. Remember what point slope form is. This was the second form of an equation we looked at. It's less useful than slope intercept, but since we're given a point and a slope, there's no reason to make this problem harder than it has to be. Point slope form is y minus y sub 1 equals m times x minus x sub 1. You're going to leave y, the equals, the parentheses, and the x. We're going to plug in sub x sub 1 m and y sub 1. Your m is going to plug in whatever it says here is going to go right there in place of your m. So 7 over 4 goes in for your slope. Your x sub 1 and y sub 1 are going to plug in as the opposites of what they say. The reason they're the opposites is because it says minus y sub 1. So this is your y sub 1 value. In place of that, when it says negative 14, we're going to plug in the opposite, positive 14. This is where your x sub 1 value goes. This is your x sub 1 value. Again, it says minus, so we're putting in the opposite of it in place right there. We're putting in positive 4. So y plus 14 equals 7 over 4 times x plus 4. And that is point slope form of a line parallel to the original equation. 17, these problems get a whole lot faster from here. Negative 2.4 to the 0 power. Anything to the 0 power is 1. Negative 9 being raised to the negative exponent. Remember, anytime something is raised to a negative exponent, it has to ride the elevator. So when it goes down, the exponent becomes positive. It becomes 1 over negative 9. Now it becomes to the positive 2 since it went down. So when we simplify this, we're left with 1 over negative 9 times negative 9. A negative times a negative is a positive 81. 1 over 81. Number 19, 3g to the negative third h squared. Only one thing, only one factor in this term is being raised to a negative exponent. G. 3 is not, and h is not. So g is going to ride the elevator down. 3 is going to stay at the top. So is h squared. When g comes down, it becomes raised to the positive third. That's why it rode the elevator to become positive. Number 20, the only thing being raised to a negative exponent is g again. G to the negative 2. It rides the elevator. Remember, elevators don't only go down, they also go up. So 6 is going to be at the top. It's already there. And h to the ninth is at the bottom. It's already there. G comes up. And when g comes up, it becomes raised to the positive 2. 6g squared over h to the ninth. 16 times 4 to the negative 2. Remember, exponents happen before multiplication in your order of operations. So make sure you do your exponents before you try to do the my dear part of my dear Aunt Sally. This has to ride the elevator since it's raised to a negative exponent. This goes down, and it becomes 16 times 1 over 4 to the positive 2. 1 over 4 to the positive 2 is 1 over 4 times 4, which is 16. So we have 16 times that. If we multiply straight across, we're going to get 16 on the top over 16 on the bottom, which simplifies to 1. 16 divided by 16 is 1. 10 to the negative 1 times 13 to the 0. Anything raised to a negative exponent rides the elevator. It goes down since it's at the top. It becomes 1 over 10 to the positive 1. There's no reason to write something to the positive 1. Times 13 to the 0. Anything to the 0 power is 1. So times 1 will simply leave us with 1/10. All of these for number 23 are 10. They're all the same base. 10 times 10 times 10. So we're going to add the exponents. Negative 6 plus a negative 1 plus 9. 10 plus a negative 1 will be negative 6 minus 1. That's negative 7 plus 9 is 10 to the second power. 10 to the second power means 10 times 10, which is 100. Both of these are the same base, 4.78. So just like 23, add the exponents. 4.78 to the negative 7 plus 7. 4.78 to the 0 power. Anything to the 0 power is 1. (25) Multiply your coefficients 2 and 3 and you get 6. You're multiplying the bases h and h. So you're adding the exponents. H to the negative 2 plus 9 is 6. H to the 7th power. You're multiplying all three of these terms. Negative 10, the coefficients first, and 5 is negative 50. Then you're multiplying the variables, c to the third times c to the fifth. That's c to the 3 plus 5. You add the exponents. Then you have only one d, and it's to the third power. So when we simplify this, it's negative 50. C to the 3 plus 5 is 8. D to the third. 27th, k squared to the 6th. A power is being raised to a power now. We're not adding the exponents. We're multiplying 2 times 6, k to the 12th. M to the 9 to the negative third. Again, m to the 9 times negative 3 is m to the negative 27th. You can't leave something with a negative exponent. Ride the elevator. M to the negative 27 goes down. 1 stays on top. When it comes down, it becomes positive 27. (29) 5h to the 4th to the 3rd. Both factors in the term get raised to the 3rd power. 5 gets raised to the 3rd power, and h to the 4th does. Remember, a power to a power means to multiply 4 and 3, not add them. 5 to the 3rd, 5 times 5, 25. Times 5 more is 125. H to the 4 times 3 is h to the 12th. Negative 2k to the 4th, j to the 3rd, all of that raised to the 4th. Again, everything here gets raised to the 4th power. Negative 2 gets raised to the 4th. K to the 4th gets raised to the 4th, so it becomes 4 times 4. And j to the 3rd gets raised to the 4th, 3 times 4. So when we simplify that, negative 2 to the 4th, negative 2 times negative 2 is positive 4, times negative 2 is negative 8, times negative 2 is positive 16. K to the 4 times 4 is k to the 16th. J to the 3 times 4 is j to the 12th. When we do the same with the other term, everything gets raised to the 3rd power. K to the 4 times 3, and j to the 5 times 3, which is k to the 12th. K to the 12th, j to the 15th. Then you're multiplying all of these bases. K and k, you add 16 plus 12. We have 16 comes down, and j and j, you're adding 12 plus 15. So you wind up with 16 k to the 28th, j to the 27th.